So in this problem there are several sources, two voltage sources, two current sources, independent ones, and there is one uh, voltage dependent voltage source. So what we need to find is we need to find each of the sources, whether it's supplying power or dissipating power, and we need to find the value of that power, whether the power supplied or the power dissipated by each of the sources. So what we have two current sources here. This is one current source and this is another current source, 6 ampere and 9 ampere. So these two current sources define the currents through these two branches, because the current source is the current through that branch. So we know these two currents. This is 9 ampere downwards and this is 6 ampere downwards. So we know what will be the current here in this branch, which will be the addition of these two. If we apply KCL, we can see 9 plus 6, 15 ampere. So 15 ampere is coming, and that is splitted between these two branches. So that's there. Now looking at the direction of the current and the polarity of the sources, we can identify whether any source is acting as a is it supplying power or is it dissipating power. We can find that out. So V0 is given, which is 5 volt. This is V0, and this voltage VA is 10 VA is V0. So basically VA will be 0.5. Since V0 is equal to 10 VA, VA is equal to V0 over 10, and V0 is 5, so this is 0.5. So we know the voltage drop here, that is 0.5, and this drop is here, this is negative and this is positive, so that is 0.5. And we can, what I will do, I will write that value here, 0.5 volt. So that's there, and this voltage drop is 5 volts. So of course we need to find what is VG, because that's not given, but we understand that we have 5 volt drop here, and this full voltage will be 5 volt, because this is in with parallel to this one. These two are in parallel, so the total drop is 5 volts. So of course VG will be, since VG, the direction, the polarity is in this direction, VG will has to be minus 0.45. So basically the voltage here will be like that, 4.5. So VG will be minus 4.5. This I have written just from observation, but if I want to write it properly, I mean in terms of applying a KVL and all, so if we start from here and go let's say anti-clockwise, we can see that there is a rise here. This one is a rise, so I will write the rise as positive maybe. So that's a rise, V0, that's 5, that's a rise. And then I have VG, which is also a rise, so plus VG. And then I have this one, 0.5, which is a drop, because I am going in this direction. I can find it's a drop, so that's minus 0.5, that is equal to 0. So sum of the rises and drops is 0, and rise, I have written the rises as positive, and drop, there is only one drop, that's negative. So what I get from here as well, that this is negative 4.5 volts. So 4.5 volts is VG. So that's done there. The polarity is just, this one's polarity is like that, that's why it's negative. So polarity, actual polarity is like that. So that's there. Now what we need to find the voltage drop through across the current 9 ampere current source. So that's also should be possible, because I won't apply KVL anymore. I will just write from observation. This voltage drop across here is 5 volts, and I have plus 15 volts drop, plus 20 volts drop here. So in order to counter that, I need a voltage drop of plus minus here. So I will erase that 9 ampere, which is not needed to be written there. So that's there. It will be like that, 15 volts. So that's the voltage drop across it. So 20 volt here and 15 volts here. So after the subtraction, it will be 15 volts in this direction, because 20 volt was in this direction and 15 volts was in the other direction. So subtracted, so 5 volts remain here. That's pretty simple. So we now have all the currents, all the voltage drops across the sources and the currents through the sources, everything we have. Now we just write down the power. So I will do one by one. this one, let's look at this one, 9 ampere current source. The current is 9 ampere, and we can see the voltage drop is, so in the direction of the current there is a rise of voltage. So this source is supplying power. In the direction of current there is a rise of voltage, so this is supplying power. So I will just write maybe supplied power as positive and dissipated power as negative. I will do just like that. So 15 times 9 is the supplied power by this one, that's there. Now this 20 volt voltage source, this one's current is also 9 ampere, and the current is going downwards. So we can see that in the direction of current there is a drop, the voltage is actually dropping, so this is actually dissipating power. So that one is minus 20 times 9, that is the power dissipated by this one. Then I come to this source, I will do this one, which is VG, which is 4.5. I identified that earlier, so maybe this is 4.5 here, and the current is downwards and the voltage drop is in this direction. So this is also dissipating power, because in the direction of current there is a voltage drop. So that's 4.5 times 6 minus 4.5 times 6, that is also a dissipated power. Then this one, this current source, which is 6 amps, and voltage drop is like that, 0.5. This polarity was actually given in this direction, so that one is, of course, this is actually the voltage control voltage of this dependent voltage source. So the polarity was given as this one in the question. I probably forgot to put the negative sign here, but that was there, the positive sign was there. But we have to just remember that this voltage polarity had to be given, because this is the control voltage of this dependent voltage source. But anyway, so this is 0.5 here. So in the direction of the current, there is a voltage drop, so this is also acting as this source is also dissipating power, basically 6.5. And finally the dependent source, we can see this is rise in this direction and the current is going upward. So this one is acting as a power supply, because in the direction of the current there is a voltage rise. So that one is, the voltage rise is 5 and current is 15, so plus 5 times 15. So now we have written all the powers of each of the elements here, all the sources here, and the sum should be 0. So let's see whether that happens. 15 times 9 is 135, that's 135 there, and then 20 times 9, this one is minus 180, then this one is minus 27, 6 times is minus 3, and plus 5 times 15 is 75. So if we add them up, we will see that 135 plus 75 is 210, so that's plus 210, and then minus 180, minus 27 minus 3 is minus 30, and then minus 30 and minus 180 makes minus 210. So basically the total power is 0, and that's what it should be. So yeah.